Hi guys, Dr. Justin Souther here, going through your semester test number 1, and we are looking at question 3. This was a little bit of a tricky question, flummoxed quite a few of you, and here we simply asked to find all the values of theta in the interval minus pi over 2 up to pi over 2 that satisfy this equation over here. 2 cos squared of theta is equal to 1. Okay. Now most of you got half a mark for doing the following. Cos squared theta is equal to 1 over 2. And unfortunately that was the only mark, half a mark that you got. So where do we go from here? Well, it's important to remember here that this cos 2 theta means that we're taking the cos of theta and then squaring it. So we're actually squaring this whole thing. So we can get rid of the square by taking the square root of both sides. We're left with cos theta, and that's equal to the square root of 1 over 2, so we can write that as the square root of 1 over the square root of 2, but what most of you neglected to add was that this is equal to plus or minus. Remember, whenever you are square rooting something that was squared to start with, you might have a positive or a negative square root. If you're given that it's the square root of something, then it's always positive, but if it's a squared that you're taking the square root of, it can end up as positive or negative. And of course, if you want to get a special angle out of this, it's most of you recognize this rather as the square root of 2 over 2 rather than 1 over the square root of 2. Right, now we've got to be a little bit careful. If you can draw a triangle and recognize your major angles, but now remember there's two angles that are going to come out for plus square root 2 over 2, and there's two angles that are going to come out for negative square root 2 over 2, and all of them have to be, you have to add a multiple of k times 2 pi or k times 360 degrees, because cos is periodic with a period of 360 degrees. So you can either draw one little triangle, or what's a little bit easier actually is to draw your angles in their standard positions. Now, when cos theta is equal to plus square root 2 over 2, remember that cos is equal to x over r. Now, r is always positive. So we've either got that x is equal to plus root 2. That's going to be somewhere over here. Let's put a plus root 2 there. And r is equal to 2. So we've got that this x value here is equal to root 2. This is equal to 2. Or we've got that x is equal to root 2 and r is equal to 2 down here. Now, in either case, you've got this little triangle here, which you should recognize as a 45 degree, 45 degree, 90 degree, which means that your y value is also equal to root 2, and here your y value is equal to negative root 2. Of course, the important thing though is the angle. This guy here is 45 degrees or pi over 4, and this one underneath here is negative pi over 4. And of course that repeats, going round and round and round and round and round continuously every 360 degrees. This negative square root 2 over 2, well, that's when r is always positive, so that means that x has to be negative root 2, so that's somewhere over here, negative root 2, and again your r is 2, so it's over there, and we've got the other angle here with negative root 2, and again the r is equal to 2. Now here it's almost exactly the same. Your y is root 2, and your y here is negative root 2, but your angle here is going to be this is pi over here, this is going to be 3 pi over 4, and this is going to be 5 pi over 4. Now, you didn't actually have to do this, and a lot of you got to the right answer without using the negative, and you still got your marks, because we're only interested in the interval minus pi over 2 to pi over 2. So we're interested in this quadrant here and this quadrant here, which means that our two answers, without having to worry about adding k to pi, that theta is equal to pi over 4, that's that one there, or theta is equal to minus pi over 4. Those are the only two values that sit in this over there. So you've got half a mark there, you've got half a mark there, you've got half a mark for your two answers. But of course, if you got the final answers, then you've got your full marks. Now that's one way of doing it. There's actually two more interesting ways of doing this, which actually are simpler in a way. And the first is very pretty indeed, and that's if we rewrite this as 2 cos squared theta minus 1 is equal to 0. Now, if you know your double angle formulas, you can recognize this. This whole thing here is equal to cos of 2 theta. Now, why is that pretty? Well, you've simplified it already, and we gave you a mark for that right there. Because this means, if you have a look at your cos graph starts at 1, and it drops down to 0 at pi over 2, and it comes down to minus 1 at pi, and it's back to 0 at 3 pi over 2, and it's back up to 1 at 2 pi. So this here is pi. So cos of 2 pi is equal to 0. That means that, cos of 2 theta is equal to 0. That means that 2 theta is equal to this guy over here, pi over 2, plus k times, remember it repeats, plus k times 2 pi for some integer k, or 2 theta is equal to 3 pi over 2 plus k 2 pi for some k element of an integers. Now we're interested in the two values that fall in this range here. We also are interested in theta, so we need to divide by 2. So therefore theta is equal to pi over 4 plus divide by 2 k pi, for k is an integer, or theta is equal to divide by 2 3 pi over 4 plus k pi theta, k pi for some integer k, and that means this value here, when k is equal to 0, falls in that range. Therefore theta is equal to pi over 4 plus 0 pi, or theta is equal to, well, this one is not in that range, that falls outside of pi over 2, but when k is minus 1, we're going to end up with minus pi over 4. And those are our two values which we already got over here. That's quite a nice way of getting them. There's one more even neater way of getting to the final solution, and that's to note that 1 is equal to sine squared theta plus cos squared theta. Now we've got a cos squared theta here and a cos squared theta here. We take that across. We've got two of them on this side and one of them on this side. Take across, subtract 1, you end up with cos squared theta is equal to sine squared theta. Now divide both sides by cos squared theta, and you get 1 is equal to sine squared theta over cos squared theta. And that, of course, is equal to tan squared theta. Square root both sides, remembering to take your positive and negative, and you end up with plus or minus 1 is equal to the tan of theta. Now, where is a tan of theta equal to plus or minus 1? Let's again have a look at, you can either have a look at your tan graph or you can have a look at the angles. Well, tan is equal to y over x, so we're looking for values when the y over the x value is equal to plus or minus 1. In other words, in magnitude they're the same, but maybe the signs are different, giving us the minus 1. But the y value is equal to the x value. In other words, we've got these two angles must be the same. We're looking at a 45-degree angle, or a pi over 4. And again, the signs can be different because they could give us minus 1. But as long as the magnitude, the x magnitude, is the same as the y magnitude, and that's going to give us the minus pi over 4. Of course, these ones are also valid over here and over here, but they're excluded because of the interval we're looking here. We're only looking for the interval between minus pi over 2 and pi over 2. So from here you can see quite quickly that theta is equal to pi over 4, or theta is equal to minus pi over 4. Okay, so there are three very different ways to come up with the same answer, and I've included them all because I thought it would be nice for you to see the alternate methods. If you're not sure of any of them, please do come and see us, and we'll go through any of them more slowly with you if you'd like.